Hello everyone, I'm Vishesh Vaibhav, the Google Developer Student Club's lead here at Amity University Gurugram. Now this is going to be our very first video of understanding the machine learning world, which entails understanding data pre-processing. Now, this is a very important topic because before we jump on and learn all the fancy things in the machine learning world, it is really important to understand data pre-processing. Now, if this is the first time you're learning about, or hearing about data pre-processing or machine learning, let me tell you what machine learning really is. Well, machine learning is a branch of AI which enables artificial intelligence models to imitate how human learn. And the main goal of artificial intelligence model is to imitate how humans learn, and usually imitate the learning process and to make predictions or to do things which if a human does would definitely take time. So this is what the main aim of machine learning is. But to understand this, it is really important to know that machine learning is a branch of artificial intelligence, and deep learning is a branch of machine learning. So if you would have to visualize it, the AI, the artificial intelligence, is a very big circle inside of which comes machine learning, and inside the machine learning circle there comes deep learning. So I hope you can visualize it like this. Now before we jump on to really understand and code these data pre-processing toolkits, it's really important to understand a bit about data pre-processing in theory, what it really is, why do we do it, because if we do not understand this, it'll really uh, not help us in the future, because if we are running a piece of code, we should understand what it really means. So without any further ado, let me just share my iPad screen so everyone could understand what we are actually doing. All right, we're ready to learn now. But before starting, it's really important for us to know that while building any machine learning model, we use data and algorithms to make these predictions, to make the machine learning model to imitate how humans learn. Exactly keeping that in mind, we'll understand the future concepts. Now, remember why I mentioned data. So, data can be anything. We can get these data from anywhere, but to get these data we need to understand that it can be taken from anywhere, right? It is what we call raw data, because nothing has been done to it. For example, if we are reading a news right now, that news can be extracted, like copied and pasted, and that can be treated as a data. Now, is it really wise to take any raw data and use it in our machine learning model? The answer is no, it's not wise, because of which we use these few steps called data pre-processing, which involves processing the data in order to be used by the machine learning model. So let's start. So what is machine learning? Well, machine learning is what we talked about right now. So this is the step that we are going to talk about, data pre-processing. So, as I told you, what it is. Now, first of all, we import the data. So the data can be in any form. So for for most use cases, if you are building a machine learning model, you can just go to kaggle.com and you can get a lot of data for your use cases. But again, the data needs to be in a way which is aligned with your technique which you are using. For example, if you're using a simple regression model and if you're building a simple regression model and you give a data which has multiple variables or multiple dependent variables, it's not going to work. If you do not understand what this means, do not worry. We are going to cover this up in our next videos. Now, first of all, we import the data, which is very important. And secondly, we clean the data. What does cleaning the data means? Well, cleaning the data just means that we are taking care of missing values if the data has any. We're also taking care of encoding. For example, if we have some data which has strings, but machine learning model does not understand strings. It needs us to convert that string into machine language, which is 0 and 1, right? And these are the few steps that are needed. It also wants us to perform feature scaling. Now, what is feature scaling? Feature scaling is nothing but to converting data in a way where the machine learning model doesn't biases while comparing the data from one to another, and which is what we'll understand further in this video, right? So these are a few steps what we use in order to clean the data. Exactly. And then after the data is clean, we take the data and we split the data into training set and test set. Now, what does this mean? Well, it's really easy to understand. For example, if you have a data, you are going to use the same data, but in order to train the machine learning model, you're going to take a chunk of it, and then a small chunk of it is used as a chunk as the test data, which is called the test set. We're going to understand future in this video, but a little later. All right. So this was the steps which is needed in data pre-processing. Now, if we are building the model, which is where we specify all the algorithms that we are going to use, the techniques that we are going to use, it is really implemented here. Now we build the model, which means we use the technique, implement the algorithms, then we train the model using the algorithms that we talked about, and then we use the test data to make the predictions, which is really called making the predictions. All right. Now we evaluate it. Now the data that we are using has made the prediction, all right, but how do we know if the prediction made is really correct? How do we know if it's really correct? Because can we just just rely single-handedly, or by closing our eyes can we rely on the data? Usually the answer is no, because we are building the model and the machine can be wrong. But to ensure that the machine is right, or if to ensure if the prediction made is accurate, we use some metrics. Well, what are these performance metrics? We're going to talk about it later. But lastly, we make a verdict that okay, this model has made a prediction, but is it really reliable or not? All right, so let's talk about training set and test set. What are they? Now, any data would have these two things with us: a dependent variable and an independent variable. Now, what it means, let us really understand. All right, so to understand this, let us understand it in a bit uh in a good way. All right, so for example, if we have um a this is a data b c d, and these are the columns that we have in the data. All right, and then we have a column e. Okay, now what does this mean? This means that we have a b c d and e columns which have all the data inside of it. Like many rows, it can have many rows, but it does not uh, trouble us right now. What we are interested in knowing is, whenever we have a data, it might have many columns, but usually in the data we are looking to predict something. We want the machine learning model to predict something. What we want the machine learning model to predict, which is usually the last column in most of the data, we call that we call that dependent variable. All right, it is called dependent variable. Now, why it's called dependent variable? Because it is dependent, the prediction is dependent on a set of features. Now, what are these features? These are the features. Now, A, B, C, and D tell something about E. Now, what it tells makes the machine learning model to do the predictions. So these A, B, C, and D are called independent variables. All right. Or they are also called features about the data. All right. I hope you understand this because this is really important to know. Now, dependent variable and independent variable. Now, these are the two things that are, mostly needed in order to, in a data, which are mostly needed in order to make the prediction. And in any data, we need to have these two things. All right. For example, we can have the dependent variable as sale price, which we want to predict, and we can have mileage and age of the car as the independent variable or the features of the car. Now, this is what will determine the sale price of the car, which is why we call it dependent variable, because this is dependent on these two. Right? Now, this was about dependent and independent variable in a data. Now let's talk about the training set and test set. Now, in any data, we are going to take the 80% of the data, and we're going to put it as a training set. Now, the data can be very huge, but usually this is a very an ideal number for machine learning world to use 80% of the data as training data and 20% as training data. Now, there might be cases where we are just taking a training data as a whole different training data, but we are using a different test data. Now, both of these training and test data should have the same dependent and independent variables. For example, if the training data was trained, the model was trained on sale, model was trained on mileage and age, and it was to predict sale price, the test data should also have mileage and age, and it should predict the sale price. All right, so this is what it means. If there's the 100% of the data, 80% would be the training data and 20% would be the test data. Right. Now we have understood this. Let's jump on to a different topic, which is called feature scaling. Now, this is also a very important topic in terms of machine learning. Okay, so here we have some data. For example, it's really, it's not important what the data tells us, but it's important to understand what feature scaling is. Well, as I told you, feature scaling is something which allows us to make sure that the machine learning model doesn't biases between comparing these values, right? Because we need the machine learning model to compare these values in order to predict something. But what if it doesn't understand these data, and it biases? It says, no, I feel that 179 is greater than 56. It is greater, but sometimes if it hallucinates or makes a mistake, it cannot usually compare the best scenario, which is why we have to use feature scaling in order to make this data in a way that it has almost the same value, so that the machine learning model doesn't have to take so much time in order to make those predictions. Now, the feature scaling is always done on columns, which means it does not go here, it does not go here, it is always performed on columns. So, what it means, so if we are performing feature scaling, we perform it on columns. All right, now when that is sorted, let's come to how many types of feature scaling there is. So there are mainly two types of feature scaling: normalization and standardization. All right. So what is normalization? Well, if you have a background of, say, SQL, you must have heard about normalization, which really means that we are normalizing the data in a way where it is easier for us to, or the machine to understand and compare the data, right? So this is what we do. There are two techniques. There are not two types, but rather they are techniques. So normalization is a technique where we use the date this formula. I would use this data to tell you more about it, but we use this formula to perform the normalization. And if we perform the normalization, our data would be in between 0 and 1. So all of this data, if we perform normalization using this formula, the data would be between 0 and 1. Now, standardization, on the other hand, means standardizing the data for the model. Now, these both techniques are acceptable, but mostly standardization is used for feature scaling. Now, if we use this formula to perform this standardization, our our data would be between -3 and +3. So, for example, all of this data would be between -3 and +3. The formula here is x minus the average by divided by standard deviation. Now, let's take a scenario and understand feature scaling a little better. And in data, we'll perform normalization. All right. So here is the data. We have salary and age. All right. And for example, this would have to predict something like X, Y, Z. Now, we do not have that for the sake of this example, but if we had a salary and age, how will the machine learning model compare salary and age? It cannot compare them. So because of which it can give us very fatal issues in our model. So in order to compare salary and age, we need to make sure that both of these data are converted into a value which helps us to understand if A is closer to B, or A is closer to C, or B is closer to A, B is closer to A, B is closer to C. Now, if we were to perform that, how would we do it? If normally we can do that by, some normal techniques, by taking the average, but it's not always the right, it does not always give us the right value. So for that, what we do is we compare using, first we use feature scaling to come to make the data really understandable. So if we were to use normalization in this, how would we do it? So, for example, I'm just going to do one of it so you understand, and you can do the later on your own. So, for example, we were to as I told you, it happens on columns. So we cannot apply normal feature scaling to rows. We cannot do that. We need to apply it to columns, right? So let's do it on this salary column. Okay, and first we are going to do it for A. So if we were to perform feature scaling for the row A, but in the column, we were to do it by, let's take x is 70,000, and then we'll take the minimum of this. So which is the minimum of this according to us? Obviously, it's 52,000. So we're going to take this, and then we are going to divide it by x max minus x min. So what is the maximum of these? It is 70,000, obviously. So we're going to take 70,000, and we're going to divide it, subtract it with the minimum of these, which is 52,000, right? Now, if I were to make the calculation, it would have been 18,000 divided by 18,000, which would give us 1. Now, if you can do this for B and C as well, and then you can do it for age, and you can do it for all these ages of A, B, and C as well. Now, then you would get a value, and then you can see that how these comparisons actually work. And now, when all of these values would have a value, a value between 0 and 1, it makes us it makes our tasks or the machine learning model's task really easier to compare, because now it doesn't have to compare salary and age, but it has to compare one, or for example 0 point something. Now it has a very fair amount of resources to compare this thing. Now that we have understood a major part of data pre-processing, let's jump on to our code, and let's code some of the really cool things in data pre-processing. All right. So here I've opened a new Google Colab notebook where we will be doing most of our tasks. All right. So in order to do this, let me first tell you how this thing goes. So after we write a bunch of code, I'm going to explain to you most of the lines, and I'm going to tell you what it really means so you understand what you are typing. Now, in order to do this, you must have a basic knowledge of Python with you, which we have covered up before in our bootcamp. But if you're not part of a boot camp, I suggest that you go on and learn some Python, basics of Python, and then come back and understand this video. Okay, so let's start. So the first thing that we are going to do, let me just, create some table of contents so we know that what we are doing here. All right. So first we will be importing the libraries. All right, so the first thing that we are going to do is to import the libraries. Now, which libraries we will be working on? We'll be using mostly three libraries, which are NumPy, Pandas, and Matplotlib. Firstly, this, and there will be one more library which will be adding on to our toolkit, but later in this video. All right, so now we have imported this data as the following. So we'll run this. So right now it's connecting to the Python 3 backend, and after this is done, as you can see, it has run without any error. All right. So the next thing that we need to do is we need to import our data set. So we'll write. All right. So for using a data set, I have created, or I have downloaded a data set from the Google from the internet, and I have a data set which we can use for the sake of this tutorial. Now I'll be using this data set, but I'll also be attaching this data set in the description below, so you can download this and follow along this coding tutorial. So I'll just upload it. All right, so the data is now uploaded. Now, after the data is uploaded, you can just, double click the data and see what the data means. Now, we have so if you remember, we just talked about independent and dependent variables. Now, I want you to pause the video and guess what the independent and dependent variable might be. All right, now that you have done it, let me tell you what the both of them are in this particular data. Now, the dependent variables are country, age, and salary. And independent variables, sorry, independent variables are country, age, and salary. And all of this make help the machine learning will help the machine learning model make the prediction of purchased of yes and no. Now this is what it really means. Okay. Now that we have understood this, we'll go ahead and import this data onto our code file so that we can use the data for the data pre-processing. All right, let's do that now. All right, so we have imported the data set. Now, the next thing that we need to do is now if we look at it, there are this is the data. Now we need to categorize this data into independent and dependent variables. Now I want you to guess which one is the dependent and independent variable in this case. Well, we have talked about it before, but the next thing I want you to guess is how do we, using our Python knowledge, how do we, take these three columns as our independent variable and this one column as our dependent variable. Now there would be many ways, but because we have imported numpy, we're going to use one of the functions in order to do this. So the function that we are going to use is ilog, which means ilocate index. So we're going to use that right now. So I'm going to close this and I'm going to write this piece of code. All right. Now that we have done this, let me tell you what this piece of code really means. First of all, we're taking a variable in which we are using the Panda dataset, Panda library to read the CSV file. Now I have pasted the path of the file here. Now after this, we are using creating a variable X which will store our independent variable. So I'm going to write it in here in comments so that we understand. All right. So this would create our independent variable. The X would store our independent variable. Now we would also create a Y variable which would store our dependent variable. Now let me tell you what this piece of code really means. Now we are accessing the data set variable and we are using a function called ilog which is allowed by us to the numpy library. Now in this line of code, if you have the knowledge of range, this line of code means that we want to access all the rows from the start to the bottom. So the data can be very long, but we want to access all of it. We don't want to leave any of the data. And secondly, we give a comma, which means we want to talk about the columns now. Now in the column we are giving a colon and a -1. Now if you have a knowledge of range, this usually means that we want to access all of the previous, like before -1 means the last one, the last column. So colon -1 means we want everything from the start, and there can be n number of columns from the start. We just want to exclude the last one. So this is usually a good approach in order to actually access our data set. Now when we do this, we are getting all of our rows, and in the columns we are getting all of our rows except the last column, which means the purchased column. We're not taking that. All right. And then we want all the values, because of which we write dot values. All right. And then we do the same thing here, but here we want all the columns as well, but here we just want the last column, which is the purchased one. And we talked about this. Why? Because we just want here the dependent variable. So which because of which we have isolated it in y. All right. Now when this is done, we'll just run this code cell. and this has run perfectly. Now we have imported the libraries and we have imported the data set. But just to check if we have done it right, we'll just print X and this would give us France and all of this. This is the country, this is the age, and this is the salary. And then we would import, then we would print Y. And this would give us yes and no. All right. Both of these are matrices or arrays, which you can call in Python. All right. So the next step that we have to do is we need to take care of missing data. Now, how do we take care of missing data? Let's just check in our data if there is any missing data. Now, if your data does not have any missing data, you do not need to perform this step. Now let's see. We have some missing data here, here, here. And how do we understand it here? All right. We have some NANs, which means not a number. So we have some not a numbers which we need to deal with. All right, so here comes a part when we need to import a library called scikit-learn. Now if you are doing it in Jupyter Notebook, you need to run this command, import pip install scikit. I'll just write it for you. So you need to run this command on your Jupyter Notebook in order to use this if you're using it to Jupyter Notebook. All right, so when this is done, we'll come back here and we are using a library called scikit-learn. Now this library would be home to all of your machine learning needs, and once we are using this here, we'll be using it a lot more often in our next tutorials as well. So here we'll write sklearn, and this is how we use scikit-learn. And from here we need a method called impute. Now, what is this? We'll talk about this later. But let me just write the code first. All right. So here, what we are doing is we are all right, let's not do this. So what we are doing is we're using the library sklearn and we are using a method called impute. Now, impute means in data preprocessing, we need to, impute something. We need to calculate something and we need to replace something. And that is done with the impute. And from this whole library, we are importing a class called simple imputer. Now, if you have any knowledge about object-oriented programming, you would know that every time we want to use a class, we create an object. So for this, I'll create an object. And to access the class, we just write the name of the class and then this two round brackets. Now, these round brackets would take some inputs, some parameters. If we talk object-oriented programming. So how do we know which of the parameters to give this? So even I do not know it. We need to Google. So let us go and search for sklearn.impute. sklearn.impute. So this would give us this sklearn.impute.simple imputer. If you remember, this is what we are using in this tutorial. So parameters it needs is missing values. It needs a strategy, right? It needs this and the missing values. So let us give us this. All right. So what are we looking to replace? We are looking to replace NANs. So because we have the NumPy library with us, we'll write np.nan. What's the next thing that we are looking to use? The strategy. Now, how do we want to replace this missing data? Now, there are many ways you can do this. For example, you can use the mean, the median, the most frequent data, or the constant. But this is important in order to give the machine learning model a very right and a concise data which has no errors. So in order to do that, what we'll do is we'll give it a strategy, and to give it a strategy, if you do not give anything, it would just compute the mean for you. But in order for this tutorial, we'll write mean because we write this in commas, inverted commas, because this is a string, and if you have Python knowledge, you would understand why. Now we have created an object called imputer, right? So let us see what is the next thing that we need to do, right? Let's just scroll, scroll, and we would see that this has a method called fit. So what does this do? Well, this means that we need to fit this. In order to replace those missing data, we need to first use this column that we have, this X variable that we have, which has the missing data and also everything. So first we need to fit it. So let us just use that. We use imputer dot fit, and then we need to fit it. And how do we fit it? X, and then again. Now, if we look at the data, what are the things that we want to, which of the columns that we want to replace? Now, we do not want to replace anything. We do not want the mean of these string values, do we? We do not need that. We just want to replace the second column and and third column. But in order of in talking index values, this would be 0, this would be 1, and this would be 2, right? So we'll be using 1 and 2. So if we were to write it in range terms, we would write 1 because 0 and 1. And then if we want 2, we want to exclude the third. So if we write 3, we would be getting the second, right? If you have the knowledge of range, you would understand this really well. Now, when this is done, this is the first thing that we would have to do. Now, let's just see what's the next thing that we need to do. We need to fit transform, which means fit to the data, then transform it. All right. So here, what we'll do is, because we are using fit and we're not using fit transform, we'll do transform here because we have fit it first and then we'll transform it, right? Let us do that. So we'll use imputer for transform. And now what does this take? Well, this just takes the variable that we want to transform. But again, because we have fitted it, we'll use this part again. Okay, let us use this. And after we are using this, what we'll do is this would return the values of the mean of the missing values, right? But this would just return it. How do we make sure it is really fit here? So in order to do that, we would just take this line of code and now, if you have basic Python knowledge, you would be able to understand this, but I'll just explain it again. Now, we want this to be performed, this imputed the transform to be performed on the columns the age and the salary. Now, in order to this would give us the missing values fulfilled. Now this would give us that, but in order to use this and replace the the filled values with the missing values, we need to perform this, which means we are using the age and the salary columns and we are replacing it with this function. So I hope you understand that, and let us run it and see if we are getting any errors. All right, so we are getting any errors. So, all right, we have done an error here. Okay, so here's the thing. Remember what we did is we first gave the rows here and then the columns. Here we have made that mistake. So here's what it says. We cannot convert string to float. Spain cannot be done. And for that, what we need to do is we need to write this, which means we want all the rows, and in the columns, we want these two only. And we're going to do it here as well. And we're going to do it here as well. Now, if we run this, let's see if we get any errors. No errors as such. Now we have taken care of missing data, but because we were, making sure that we are creating a table of contents, we're going to do that. All right. Now, when this is done, we have taken care of our missing data. Now, if we print x, let's see what it gives us. It's giving us the mean values of the data. All right, that sounds good. Now, the next thing that we have to do is encoding categorical data. Now, this is important, so I want you to listen. All right. Now, the next thing that we want to do is we want to encode our categorical data. Now, what does this mean? Let us open um, our data, for example. So this is the data that we are using right now. Now, what we want to, first of all, we would not be able to use strings and give this information to the machine learning model for predictions because it's simply not possible. Now, secondly, we would see that there are a few repeated values here, repeated as mean categories. So if we see how many categories of France do we have one, we have two, we have three, and four. We have four categories of France, and you can count for Spain and Germany. Now, what we want to do here is we want to create the columns for these categories. Now, why are we doing this? Why are we even performing this thing? Because it's very simple. Why cannot we use this simple term here? Now, to understand this, let us jump onto our iPad for a little bit of theory again. Okay, let's do that. All right, we're back again here at iPad. So, this is the same notes that I used in our AIML bootcamp. So we have taken care of our missing data. So we could just do this, and we have done this. Sorry. So we have done this. So let's just come here. So now we want to encode our categorical data. Now it is difficult for our machine learning model to understand string or text, right? So what do we do? How do we make sure that this data that we are using, France, Spain, Germany, and all of that is converted into a value which is, understandable by machine? The first thing that we can do is we can use 0, 1, and 2, right? Sounds fair because we can give France 0, we can give Spain 1, we can give 2. Now the problem with this is that the machine learning model can think that, okay, if this is 0, 1, and 2, what stops from Spain being 3? Because this can happen, right? It can think that there is a numerical order for all of that. It can think it's a machine learning model. It does not know what we are trying to imply, right? It can happen. So in this, if you have a very small data which is only, like, for example, a small data which has France, Spain, for example, two countries here, so you can use this approach. The second approach would be one hot encoding. Now, what does this mean? Let us understand it. So, one hot encoding means that we want to create a column for each category. So, in our case, France, Spain, Germany are the three categories. So, how many columns would we have? Three. We would have three columns. Now, this is what one hot encoding tells us. But how do we do it? How do we ensure that what we are making is understandable and it's unique as well, right? So we create binary vectors. Now, if you do not know what binary vectors are, let us just jump back to a concept called binary. Now, 1 0 0 0 1 0 0 0 1. So if you have made truth tables before, like 1 0 0 0 0 1 0 1 0 and something like that, 0 0 1, something like this, you would understand that what it really means. Okay, so this is what it does. So because we have three columns, we are using three numbers, right? Three numbers. So this means that we want three columns here. So we are assigning France 100, Spain 010, and Germany 001. Now all of this would be created into three columns. Now 1000 would have a column of its own, 010 would have a column of its own, and 001 would have a column of its own. Now this is what it really means. Now one hot encoding ensures that all of this string data is converted into a numerical data because it uses binary vectors to do it. And when we perform this, we will see how this actually works. All right, so let us jump onto our notebook and perform this. All right, so now we are back onto our notebook, and let me just close this. This is the same data that we're using. Now you would see that this data hasn't filled it because this is the raw data that we are using. All the changes we are making is to the variables that we have created just above. All right, so we want to encode the categorical data. Now, as I told you, we always, when we are using this, we will be using our beloved library, which is called scikit-learn. Now, from the scikit-learn, we'll be using some things, but first of all, we need to encode two data. Now, if you see, we have a yes and no as well, and we have this France, Spain, Germany as well, right? So let us do that. First, we will be encoding the independent variable. There are two steps to this. First, encoding. All right. First, we'll be encoding the independent variable. And for this, for any of this, let's just import two libraries. First would be from sklearn.compose. We want to import column. All right. Google Colab does that for us. And the second thing we need is, all right. So we have to import these two libraries, sklearn.compose and sklearn.preprocessing, and we want to import one hot encoder, which is what we talked about right now. Now, column transformer, what is this? We want this. Why do we need this? We need to use, and we want to, convert this columns into something. So we use column transformer, and one hot encoder is the technique we just talked about right now. All right. So the first thing we'll do is we'll create an object which we just did just above, remember? and we'll just create an object, and secondly we'll call the class. Remember, this is what we do. So what we'll do is this takes some parameters. So how do we know which parameters this take? Again, we're going to go ahead and we are going to see what it really takes as a parameter. So it takes transformers, it takes, okay, so drop, pass through, something like this, columns, all right, remainder, all right. So what are the things that we actually need here, right? So the thing is, because it's a really long list of things, how do we know that, okay, this is the thing that we usually need? All right, so this is the thing that we are going to work on right now. Now, if you see, this has a particular, syntax. So this uses square brackets to do. So we'll be using that. And anything else? Okay, let's just start it and let's see if what are the things that we need. All right, so the first thing that we understood it needs this, right? Square bracket. And the first parameter it needed was transformers, right? It is a list of tuples. All right, so it needs transformers. So if it's a list, so first of all, we're going to give it transformers. All right, so we're going to give it transformers, and we saw that it takes a list of tuples like name, transformer, columns, and everything it takes here. What we'll do is we'll give it as a list. Okay, now sounds good. And secondly, if it's taking a list of tuples, if you saw, so it's taking list of tuples. So if you know what tuples is, it's a data set in data structure in Python. So tuples are they always come in this round brackets. Now, first of all, what do we need to give it? What are the thing that we are using? We are using encoder. All right. Which is the encoder that we are using? We are using one hot encoder, right? And why are we using these two round brackets? Because it's a class, and always when we use a class, we use this. All right. And we are using one hot encoder. All right. And let's see, what is the next thing it is asking from us? It is asking from us the columns, right? We have used the transformer, which is the transformer, which is the one hot encoder. We use the name also, the encoder. And let's see the columns. What are the columns that we need? Well, in this, we only need the first column. And how do we call the first column? Pretty easy. It's zero. So that's how we call a list, right? All right, sounds good. Okay, so we have taken this now. Now transformers is done. Now let's, all right, so I have written transfer. This should be transformer. All right, column transformer. All right, and this is a spelling mistake. This should be, all right, this should reflect it very soon. Now it has, we have given transformers, and let's see what the next thing it asks for us. All right, so we have given the transformers, right? And we need remainder. So all right, so we have used the first column. What about the next two, right? So for this we use something called remainder. And what do we want to do with the remainder columns? Do we want to drop it? Means you want to delete it, or you want to pass through? You want to, just look forward, do not use it ever again. Something like that. What do we want to do? Well, we want it to pass through. So what do we write? Pass through. All right. Okay. Now let's see what it is giving us the error here. It says transformers, then substricts are not allowed. All right. Okay. All right. This is a mistake that we made here. Remember, this is a class we talked about. This is a class. So if we put it here, this should work. All right. Column transformer, this should actually work. Let us see. All right, this is the line. If we get any error, we'll be solving it as it comes. Okay. And the next thing that we need to do is, now this would return us something. Okay. This would return us something. Now, what do we want to do with it? We want to fit it in our column. We want to fit and transform it in our column, just like we did it above. So we'll use the X column, and this would be fit dot transform. And how do we know when to use this? Well, we just use fit dot transform as a method of ct. So let's do set ct dot fit transform. for. Now, how do we know we do this? Well, it's all here. It's all here. Fit transform, fit our transformers, transform the data, concatenate, add the results, right? So fit transform. What do we want to do? We want to transform X, right? Fit transform X. And now the thing is, this would return us something which is not, say it's not an array. But here, if you see, it's an array. So what we'll do is we will convert this to an array. And how do we do this? np.array. All right, np.array. This is how we do it. All right, now when this is done, what we'll do is this would return us the transformed value of X. So we will just, you know, just do this in order to make sure that this is replaced with the X variable is replaced with the new values, which is the encoded values. Now, if we run this, we are going to get an error, unmatched. Okay, so if we just do this, all right. Now, if we run this, this should not give us any error. All right, let me see what are the different, what is the error here? All right, so this is not a list. The list is transformers. All right, so column transformer takes some parameters, which are some normal parameters, and then the list is transformers are a list of transformers are a list of tuples. So the parameters would be the normal, and transformers are a list of tuples. All right, so if we run this now, all right, it runs. So if we now print X, let us see what we're getting. All right, so now we can see that we have got France as 100, uh, this as 001, and this is 001. All right, and now we print Y, this would still be the same, right? This is still yes, no, and yes, no. So what we are going to do now is we're going to encode dependent variable. All right, so how do we do it? Well, it's you can not just put it 1 0 and 1. You cannot just give it a binary vector because it's 0 and 1, yes and no. So what's the best thing you can do with 0 and 1s? Well, yes and no, you can convert it into 0 and 1s. So that is what we'll do. So we'll again import a library from the sklearn. SK All right, so we'll import a library called label encoder. Now, this label encoder, what it does is it gives us a way to convert these yes and no's into 0 and 1s. So it's labeling them. So again, if we have imported a library, we need to create an object which I'm calling LE. Then what we need to do is we need to call the class which is label encoder, and after this, we want to use this and we want to fit transform. Again, it's giving us the example. Now we're going to fit transform. Which column? Which variable? Well, it's Y because it has all the yes and no's with us. And after we are doing this, it would return something. And we want to take that returned value and put it into our original column, which is Y. I hope this makes sense. And now if we run this, we would be encoding our uh, dependent variable, and if we print Y, we would be getting 0 1 0 0 1. Now all of this is correspondent with the previous value. All right, so if we come to this, we have encoded our we have imported the library, imported the data set, took care of missing data, and we have encoded the categorical data. Now what's the next thing that we'll do? Well, we will train test split, which means we'll split the data into two, training set and test set. Now we have talked about training set and test set before, so we'll not talk about this in theory. I just want you to go back in the video and learn what it is. All right. So what we'll do is I just create a code cell here, text cell, sorry. All right. So now we'll split the data into training set and test set. Now, for to do this again, which library are we using? Well, it's scikit-learn, right? We have used this many times. So that is what we are going to do. But before that, let's just understand. a bit about it. So remember what we talked about. We want to use this and we want to convert this data into training set and test set. And what is the ideal value? Well, you guessed it right, 80 and 20, because we talked about it. So for example, I do not know which library I want to use for this. It's not always easy to remember these libraries, compose, column transformer, right? How do we know that? So let us do a normal, Google search. We're going to take this and which is scikit-learn library to use model. We can call it anything to use for the data into test set and training set. Well, it would give you this, the scikit-learn documentation. So we are going to use sklearn.model selection. So that is what we write because that is what Google is telling us. So from sklearn, what are we going to import? Well, it's train test split. So let's try that. Train test split. All right, no errors here. So because we have imported this, we want to create a object now. So we'll call this split. But what we can do is, other than creating an object, what we can do is, obviously we'll be creating an object, but what we need to do is, it needs the sequence of indexables with the same length, the test size, the training size. Now it needs arrays. So yes, our data is array, and it needs sequence of indexables with the same length or shape, right? Now, this is what it needs from us. So let us understand what we need to do first, all right? Then we would see it. So we need to convert the data into training set and test set, which means the X variable, which has our features, would have a training set of its own, a test set of its own. The Y, which has our purchase decision, would have a training set of its own and a test set of its own. Right? Sounds good. So how do we do it? How do we, actually do it? So first of all, let's just, use this. Okay. So first of all, let us just, make this variables that we're talking about. So X would have a training set, and then X would also have a test set. Y would have a training set, and Y would also have a test set. All right, sounds good. So this would be our variables or our objects. And which class are we working on? Well, it's train, test, and split. Now this would again take some parameters. It says arrays any. So it needs some arrays. So what are the arrays that we are giving it? Well, we are giving it our columns as our arrays. And which are the columns? X and Y, right? Because this is what it wants from us. What the next thing it needs? Test size. All right, so we're giving it test size. So what was the test side we talked about? Remember, it was 20%, 80% as training data and test data as 20%. So if it's 20%, 20 by 100, if we convert it in decimal, because it's float. So float value would be in decimals. So if we want to give it, it should be 0.2, right? Exactly. 20 by 100, it's 0.2. So let us give it 0.2, which means 20%. All right. Is there anything else we want to give it? Let us see. So random state, is this something we want to give it? So it controls the shuffling applied to the data. Do we need any shuffling? Well, we can because it's a data. We want it to be as random as it is so that our accuracy is maintained. So we'll keep random state is equals to 1. All right, when this is done, we just run this and this should not give it any error. Now remember, we use the documentation to do this. Now you can use the documentation to do almost anything, but it's important to actually read the documentation and understand this. Because if I read it like this, it would be all gibberish to me because I do not understand anything what it is giving me. So it's giving us the parameters, it's also giving us what it returns, right? So it's important for us to understand this. So now we have this X train, X test, Y train, and Y test. So if we just go ahead and print X train, what are we getting? Let us see. We are getting the exchange data, which means it has shuffled it now. And if we print the Y chain data, what it's giving us now, it's 0 and 1. So this one had a previous value of 0. So this data is shuffled now. So if you would see this would have a value of 0, which means yes or no. So if you just go ahead, go back and see our data, you would see that, okay, all right, so this Spain with a value of 58, 52,000 had a value of no. which means it's giving us no. So yes is one and no is zero. So right, we know that it's actually very understanding for us to it's very good for us to understand this, because it really gives us that sense of understanding of what we are doing, because if we learn and understand, it's really helpful for us. All right, so we have done this as well. So you can print all of the X-train and X-test data to see what it really is, but I'm not going to do that. And this is the last step that we are going to do, which is feature scaling. Remember, we talked about feature scaling. If you do not remember what is feature scaling, just go back in the video and refer to our theory part. So we'll write feature scaling, and let's just bring it upwards. All right. So this is the last step in our machine learning data preprocessing template. So all right, let's do feature scaling now. All right. So again, to perform feature scaling, which scikit library to use for feature scaling? Let us see. So it's giving us pre-processing data. This is what we have to use. Standardization, all right. So we know that we are going to use pre-processing data. So that's the library. So what are we going to import? Now, how do we know that? Well, we are scaling the features to a range. We need we need a scaler, right? So it's possible to disable. All right, so we need, let me read it. I'm doing it with you. So the previous model was a standard scaler. So we need the standard scaler, and standard scaler does it as standardization. We talked about two, right? Normalization and standardization. So what we need now is standardization. Remember min max? Remember what it was? This is what it is. X minus x min by x max minus x min. Remember the normalization part, which is that a back while. This is the this was the uh, formula that we used, right? This is what it is. All right. So now we are what we are going to use is standardization. So we are going to import standard scalar. All right. And now that we have done that, let us case an object, which would be standard scalar. All right. We have done this. Now, this does not take any input as we saw. So it did not take any input, but now we need to do something which is called fit and transform. Remember, because it's really important. So if you just go ahead and see what are the things that we need to do, you would understand what it is. Now you would see encoding categorical features here as well. You would see normalization as well. So you would see all of these things here. So let us go ahead and use our data to perform it. So we have created an object, so we are going to use fit transform. So in most of the models that you build, this would be a standard feature, fit transform. So again, the spelling is wrong, fit transform. Now, what would this take in its you know parameter? Let's see. X array of like X shape, fit to the data and transform it. So what do we want to fit here? What do we want to feature scale here? Well, it's simple. We want to feature scale our training data and test data, but we want to only do that with our features, right? We do not want to do it with our, for example, yes and no data. Is it important to do it with our yes and no data? It's really not important because it's zero and ones. What are we converting it into? We do not want to convert it into anything. So we would just use so transform, and we would just give it what our training data, which is X train. All right, now that is done. What is the next thing that we need to do? Now you would say that I talked about test data, which has no information about the training data, right? And that's really fair. But for example, if we are giving our training data a value between +3 and -3, because remember, standardization converts our value into +3 and -3. Now, if we are doing that, but we do not do it with our X test, would it be fair for the model to compare a data which has values like something like this, and it something like 100 35 58, and convert it with a value between +1 and +3 and -3? It's not really fair. So that is why, to make it fair, to make the machine learning model compare something which has its own value, we also do that with our X test data. Features only. I'll tell you why. Let us copy this, let us paste this, and let us just use X test. All right. So now that this is done, I'll tell you why we are not doing it with our Y chain data. Well, let's just run this first. Let us see if we are all right. So now this has returned us an array. Now you would see that this has returned us an array, but we want to, put this somewhere, right? We need to use this return data and put it into our actual data. So how do we do it? Just do it like this. We did it a lot of times today. So X test and this. And if we do this, now the return data would be fit into our variables. All right, sounds good. Now, why are we not doing it with our Y train and Y test? Now let's take a look at that data. Now, the data was like this. The features were stored in X. What we did is we took 80% of this and we can put it into X train. And then we took 20% of it and we put it into X test. Now, why? What did it have? It had the purchase decisions. Now, we took 80% of this, put it in Y train, 80% of which we put it in Y test. Now, a value of 0 and 1s, do we need to really convert it into a value between say +3 and -3? It's already in 0 and 1s, right? It can compare a value between 0 and 1 is between +3 and -3. It's really easy for it for us to compare that. So we'll just like let us print and see what we are getting here. If you print X train, we are getting a value between this, which is between X +3 and -3. So it's +2 and -2, but you can really understand that what it means. So it really depends what the actual value is. You can get a different value. It doesn't matter, but you understand what it gives us, right? It gives an array of this. So this is what our, if we can do that, we can do the same for X test as well. So let's see what it gives us. It gives us an array of -1, 1, 0, 0. All right. Okay then. So now we have got this. What does it tell us? Now it tells us that now we have a data which has performed data pre-processing on it, which means we have taken care of missing data, we have encoded the categorical data, we have split the data into training and test set, we have feature scaled the data. Now we have done all of this. Now in any machine learning model that we are building, let me just all right, so in any learning model that we are building, it is important for us to data pre-process it. Well, how it is done? This is how it's done. Now you have the whole toolkit with you. Now I want you to save this Google Colab notebook with you. And in future, if you are doing any machine learning model, building any machine learning model and you want to data pre-process it, you will do it likewise. Now, in many machine learning models, you won't do not have to do all the steps. Sometimes it's just, easy for us to compute some of the steps because it's really necessary in the data. So according to the data, you will have to perform these steps. So this is all from this video, and I hope you understood the very basics of data pre-processing, because in any machine learning model, this is what you will have to do every time. So this was all from me. This is Vishesh Vaibhav signing off, and thank you everyone watching for watching this video. Meet you in the next video where we'll talk about simple linear regression. Thank you.